As programmers, exceptions are essentially the bane of our existence. And if you're a C# developer and you've created anything beyond a simple hello world program, it's very likely you've encountered some type of exception. But even though exceptions always seem to give us a hard time because they're the reason we spend all of this time debugging, we still seem to write code that throws exceptions on purpose. So why is it that we do that? If we don't like them so much and they're such a headache when we're debugging things, why do we keep writing code that throws exceptions? Now, in the last video I put out about exceptions, which I'll link up here if you haven't seen it already, we talked about the different ways that you can catch exceptions and the right way to be able to throw or rethrow an exception from a catch block and not lose your stack trace. Now, if you're interacting with code that you don't control and it can throw an exception, you probably want to create some type of protection for yourself. But if you do control that code and you are throwing an exception, why are you doing that? So in this video, we're going to talk about some different options that you can leverage to not actually be throwing exceptions, and we're also going to look at the performance impact of doing that. Because once you see that, I think you're probably going to change your mind about all the different areas that you're throwing exceptions in your code. Now, before we go over to Visual Studio, one disclaimer is that I do try to remain pragmatic, so the fact that I'm kind of making fun about throwing exceptions, I am exaggerating a little bit. There's a time and a place for probably everything. So if I sat here and told you, oh, you should never throw an exception, that's just not reality. But I think, personally, exceptions should be intended for exceptional cases. And I think one of the challenges that we end up having in software development is that if we take a smaller lens into the code we're looking at, it's very likely that you would consider a case to be exceptional in the lens of that area that you're looking in. However, in a larger system, and when you start combining these different things together, an exceptional case here and an exceptional case there, in the grand scheme of the entire application, may not actually be an exceptional case to worry about. So it's not that you should never throw them, but I do think you're going to want to reconsider some options that you have after we go through this. So with that said, let's jump over to Visual Studio. Alright, so I'm here in Visual Studio, and I'm actually using the same solution from the last video, and what I've done is I've added some benchmarks that we're going to be looking at. And instead of creating an entirely separate example, I'm just going to use the benchmarks to explain the different variations that we can go looking at. So the two different classes that I have that we're going to be benchmarking for sort of the normal cases that we were looking at before have to do with the implicit and explicit throwing. And what I mean by that for implicit and explicit is if I go expand this explicit one, it'll be a little bit more obvious. But if we go look at something like method 1 here, where we have this try catch block, when I'm talking about an explicit rethrow, I mean that we're taking the exception that we capture from the catch block, nesting it inside of the inner exception, and rethrowing a new one. Conversely, an implicit throw would look something more like this. And this implicit throw, as the name suggests, is that it's actually implicitly just throwing the exception we already caught. And if you recall from the last video, if you did go through and watch that, what we don't want to be doing is this, because this will actually lose the stack trace of the exception we caught. That was really the lesson from the last video. So the two base cases that we're going to be looking at are when we actually have an explicit throw like this. And if I just kind of scroll through this to show you what's going on, because the other class will look very similar, we have an entry point to the class. I'm not very creative with my naming, so I apologize, but this will be the entry point. We're going to have a try catch block around the whole thing, and we're going to call method 1 from the entry point. And you'll notice here that it's a Boolean return type. In hindsight, after I put this example together, I probably should have used something like an integer or whatever, just so that you don't totally see exceptions and booleans being synonymous with each other, so I apologize for that. But in this particular case, I am kind of meaning that, as you see right here. So in the exceptional case, I will return a false, and in the happy path, I will return a true. This will make a little bit more sense as I go explain the other scenarios. So if we go look at method 1, it looks very similar, right? I have a try catch block. I'm just going to be rethrowing an exception that we catch and putting that as the inner exception. If we go to method 2, it's very similar, right? There's a lot of copy paste going on. In fact, we might actually catch a bug if we keep scrolling through, but keep your eyes peeled. So method 2 will call method 3, do the same type of thing. Method 3 calls method 4, and I ended up stopping it right at method 5. So when we call method 5, that's where we're going to be throwing an exception. And the point of the example code being structured like this is that we can show that when we throw an exception in some nested method and we want to go catch it and then throw a new exception, sort of passing in the caught exception as the inner one, like you see right here, we're going to want to measure the performance of that versus just the implicit throw. So let's go check out the implicit throw variation of this, and it's going to look very, very similar. So as I scroll up here and expand this part, we'll notice that we also have an entry point, exact same type of setup where I just have a return false when there's an exception, and we're going to turn true when there's no exception. If we look at method 1, I'm not going to bore you with kind of explaining it all over again, except for this part where I'm not rethrowing explicitly by creating a new exception and passing this as an inner one. I'm just implicitly throwing the exception that was caught. If I quickly scroll through the other ones, you'll notice that they all just have throw until we get to method 5, which is where we actually have this exception that we're throwing in the first place. So hopefully those two comparisons make a lot of sense. They're very similar, except the implicit and explicit throw, like I was trying to call out in the other video. Alright, so the main point of putting this video together is to show you the differences when you're throwing exceptions on purpose versus avoiding them altogether. So the two classes we looked at have some logic that at the very bottom, that last method, method 5, because I'm so creative with my naming, that method actually throws the exception. Now, when we go to look at the other class, this one's not going to throw exceptions, but instead of just showing you that right away, I wanted to give you a more practical example to think through just so that you're not going, well, this is super contrived, I don't really get the point. So a common place that I see this type of thing that you may have control over in your own code if you're writing things like this are parsers. So if you're writing code that parses input, parses a file, parses something from a website, maybe you're looking at website text and you're looking for a particular part of the HTML, whatever it happens to be. When you're writing parsers, unfortunately, we have situations where we don't always control the input. If you're writing a parser, in the context of your parser, you might be saying, hey, it's an exceptional case if we have invalid characters or the structure that we're looking to parse is not as expected. And that might be totally fair. If your program is a dedicated parser or you're making a library that's a dedicated parser, perhaps from your perspective, having invalid characters, bad structure, whatever it happens to be, you consider an exception. The alternative lens that I want you to have as we walk through this is thinking about what that might mean if we instead don't throw exceptions. Because what we're going to see is a performance difference between the two, spoiler alert, but how much of a performance difference I think is what's going to surprise you. If you had a parser and you had all of this code that was looking for the proper format so you could extract the right pieces and parse what was necessary, instead of throwing an exception when you come across some format that's not expected, I would say if you switch that to instead return a Boolean or some other type of state, you could use an enum, whatever it happens to be. Maybe in this case, you do want to return the exception so that there's some information associated with why it's invalid. You have a bunch of different options, but instead of throwing that exception and letting it bubble up, instead switching to some type of return value that indicates a success state and the actual value that you want to have when it is successful. If it's not successful, you would just have some other state on the return type. There's a bunch of different ways to do this. I have articles and videos that show other ways. We're going to look at using a tuple. I think people pronounce it tuple. I can't say that, so I am going to say tuple in this video. I apologize if that drives you nuts. Let's go back to Visual Studio and look at some tuples. All right, so if you're not already triggered by my usage of the word tuple instead of tuple, thanks for sticking around. Let's go look at this non-thrower class that should demonstrate very similar functionality, but instead of throwing, we're going to be returning some values. I'm going to come back to this because until we see how this is actually structured, it may not make a lot of sense. Let's start instead from the very bottom in method 5. Okay, so in method 5, in the other examples, we were throwing an exception. What I have highlighted here might be a little bit confusing if you're not used to this syntax, so bear with me as I explain it. What we have instead of a Boolean on the return type or a void in the other examples is that we have a tuple or a tuple of exception that's nullable and a Boolean that's nullable. Now, this isn't my preferred way to do this. I just wanted to demonstrate it for this video so you had a visual example that we could show both of these things. I'll elaborate on this a little bit more as we go through the example. So instead of throwing an exception in method 5, what instead we're doing is having a return of a new instance of this tuple or tuple, and then we're going to make a new exception, right? This is very similar to before, but instead of throwing, we're just making a new one. The difference is that when we throw an exception, we actually have to acquire some of the stack information. So getting that trace and being able to show that in logs and stuff, that information gets jammed into the exception when we throw it. In this particular case, there is no stack trace. That's something to keep in mind as we go through this. The other thing that we're doing is because the other examples had a Boolean, I am doing the same thing here. And this is just the reminder that I said at the beginning where I said I probably shouldn't have picked Boolean because I don't want to confuse you between having a Boolean and an exception here. If this was an integer, it probably would have made the example a little bit more clear. So having false or having true here doesn't actually matter. This is just signifying the return type that we're interested in, and this is the state that will tell us if it's a pass or fail. To give you another example of how this could be structured, let's look at this method that I just whipped up super quick. Instead, I've actually used a Boolean and a integer that's nullable, and you'll notice that I'm not using an exception anymore, it's just a bool, and I'm calling it success. I've named these, which I could do up here as well, right? I can put stuff there in the names, but the example that I want to illustrate here that we're just going to apply to the other part of the code is that we have some piece that is going to indicate state about pass or fail. So here I'm using a Boolean, here I'm using an exception or null, and then the second part that we're doing here is actually the value that we're interested in. So if this were going to be a false value on the return and the number that we want to return because something failed, we'd probably put null here. Right? So it might look like this on a failure. That's the difference that we're looking at here. So that's the point of structuring it like this, where we have one part that is a pass or fail state, and the other part is the value that you're interested in if things work. So with that said, that's what this means in method 5. The hard-coded example that I'm using is that this is going to create an exception, not throw it though, and that we're passing back a true. This could be a false. It doesn't really matter. But the point is that this is indicating a fail here because we do have an exception. Now you'll notice as I scroll up through the other methods, I'm not putting a try catch around everything. I don't need to have a try catch because the intended point of this signature is that we are supposed to be indicating a pass or fail with this exception, and then the value that we're interested in is the other part of the tuple. So if I keep scrolling, you'll notice all of them have the same format, no try catches, because we don't have to worry about that, until we get to the entry point method, just like the other examples, and still you'll notice that I don't have a try catch. So again, the Boolean choice was kind of silly of me. I don't mean for that to be confusing, but what this is going to mean, because I wanted to keep this part the same as the other examples, is that we will return true off of here if there's no exception, and we'll return false if there is an exception. And that's why here we can see this syntax where we're checking item 1, which is the exception. I could have named it like I said, so we could have done error and then made this part error. That would be a lot more readable. We have that option. I just didn't indicate it here, but this means a pass if it's null and a fail if there's an exception. And just to kind of make it more clear, I was saying, yeah, we would probably do something with the result. So item 2 in this case, if we really cared, but we're just going to be benchmarking this hard-coded scenario. Now, before I go run the benchmarks, I just wanted to talk about this return type because I said a little bit earlier, I'm not actually a fan of doing this. I just wanted to illustrate how this works with a tuple or tuple because of the visibility of these objects here. Personally, how I like to do this is I have a dedicated return type that I've created in my own libraries, and you can actually use one out of the box with a NuGet package called oneOf. The oneOf NuGet package allows you to have a class that can have, as the name suggests, one of 2 different types on it. So it's very similar to how we have this syntax where we have item 1 and item 2 that we can check. It's really a type that can have, as it's instantiated, only one of two different options. You either, in this case, pass in an exception, or you pass in this. It cannot be both types at the same time. So the one of NuGet package allows you to have that. That's something I might recommend if you're interested in this kind of syntax here. And the one that I created actually uses implicit operators in a similar way to the one of NuGet package, but I wanted to roll my own mainly because I wanted to learn about it. So that's what I like using instead of tuples here, but that's really up to you. If you like this syntax and you want to make it more readable, like I said, you could do something like exception as the name, and then you could have value. And that way you don't need to deal with item 1 because it's a little bit misleading, harder to read, and you can do this kind of thing. So that's totally an option if you do want to stick with these tuples. Okay, you're probably sick of me blabbing and you're like, Nick, just show us the results because you're talking up throwing exceptions as being this really bad thing and not throwing them as being super awesome. So let's go see the difference between running these, which throw exceptions, against this non-thrower, which just passes information back and does not do any try catch. Okay, so by the time I can even introduce what we have on the screen here, your eyes have probably already figured out where the results are and the staggering difference that we have. So the implicit rethrower and explicit rethrower benchmarks that I have here are at 38,000 and 37,000 roughly microseconds, which is going to be 38 and 37 respectively in milliseconds. So if we look at that compared to the non-thrower, right? So this case here that does not throw exceptions, but instead just returns the state, it is 3 orders of magnitude with respect to the speed that it runs at. That is absolutely staggering. If you think about running code that is going to be in the hot path of your application and it's throwing exceptions, right? So you have something that's parsing data and using a parser you've written that throws exceptions when there's an invalid character, instead of just returning true or false, or even returning an exception object with information about why it's an exceptional case for your parser. Look at the difference that we have here. And I just wanted to add that if you're looking at these benchmark results and going, okay, well, I can see the data, but I don't really want to trust it because the examples seem pretty made up, kind of silly, I wanted to add that in my professional experience, I spent years at a digital forensic software company writing software that would scan hard drives, mobile phones, looking for patterns of text. This meant that we would have all sorts of cases across gigabytes of data where we had no control over the format. So I've spent a ton of time personally writing parsers of all different kinds, and what we noticed, especially in the early days when we were in startup mode, was that we had tons of code that would try catch on different things, and we realized that that's absolutely destroying our performance. We needed to move away from try catch around everything and start saying, look, it's not truly an exceptional case. The difference was that when we were calling code that we did not control and that code was throwing exceptions, we didn't have much of a choice. So instead, we would try to pre-validate things before letting that other code throw an exception. We were trying to do everything we could to squeeze performance out of this. Another data point, if you don't want to believe me, is on the other video, we actually had someone awesome from the gaming industry commenting on that video and indicating that they don't even use CSharp for this kind of thing, and they've absolutely seen these situations with exceptions destroying performance. So if you don't want to believe me, go back to that other video, check out the comments, and you'll see from someone in the gaming industry that's had a heck of a time having to deal with this. Okay, so to summarize this video, we looked at benchmarks that were comparing code we saw in the previous video about throwing implicit exceptions, so we'd catch them in the try catch block and throw that implicitly, and then explicit throws where we would actually create a new exception and nest the other one that we caught as the inner exception. We compared those with a new approach that actually has nothing to do with throwing exceptions, but just to make it more comparable, we still used an exception object and just returned it instead of throwing it. Now, the benchmarks are pretty staggering, and if you were paying attention, I actually didn't call this out, but the benchmarks show that the implicit throw, which should be doing not much extra work, was somehow actually slower than the one where we were rethrowing a new exception and passing in the inner exception into that. I can't really explain that yet. That seems a little bit bizarre to me. They were comparable, but it doesn't make sense that we would be creating a whole new exception object and passing in a parameter, and the other one that just rethrows implicitly was somehow a little bit slower. So if you had a keen eye, good job, you caught it. But the one that I was trying to call out more specifically for this video is that when we don't throw exceptions, but instead avoid them altogether, we can actually cut down the time a dramatic amount. So the question that I want to put back to you is essentially when you're looking through your code, truly consider if you're dealing with an exceptional case and you need to throw an exception to halt execution, or if it's just a case that you're not really happy with, and instead you can return some state to say, this is no good. I don't know your code. You know your code much better than I do, so I don't want to dictate what you should and should not do. I just want to give you some variations that you can play with so that if you're looking to optimize, you can. And with that said about variations, we also covered a couple of different ways that you can have return types for this kind of thing. I showed in this example using a tuple that has an exception as the first part and then the value that we're interested in as the second part, and we can use that to have one return type that has the state to indicate a pass or fail, in this case using an exception or null, and the second part actually has the value. I also demonstrated you can do the same type of thing with just a Boolean flag as the first part. You could go make an enum as well. So all of those are options. And the other thing I called out but didn't demonstrate in the video is that I use personally something that's like a one of type, and you can actually use a NuGet package for this, and that return type allows you to essentially either have a state piece of information or like an exception, or the type that you're interested in if it's successful. So using something like that as the return type, you can totally avoid throwing exceptions if you don't want to, and instead return the state. So there's a couple of different things for you to play around with handling exceptions in your code. If you don't want to be throwing them anymore, you actually have some options to speed things up. And in my opinion, it makes the code a lot more readable when you don't have to worry about try catching everywhere, but can instead explicitly check for different types of errors. Personally, I like it a lot better. So thanks so much for watching. I hope you got to learn something cool about this, and we'll see you next time.